So we're going to begin our study of atomic structure with a little bit of history, because we haven't always known and understood that things are made of atoms. So how did we get here? I want to show you some of the key players in the idea of what we call atomic theory. So I'll describe atomic theory for you here. So let's first put a heading on this, just so as you organize your notes, you have things laid out and you can find them. Right now is a good time for my pen to die. So atomic structure will be our unit name, and we'll call this part of the unit the history of atomic theory. Remember, if I ever write too fast for you, you can always slow it down or stop or pause. Okay? Atomic theory will be kind of the theme for today. So one of the ancient questions that people asked is, what is all the stuff around us made of? And one idea at the time was that whatever it's made of, you can just keep cutting those pieces smaller and smaller and smaller. So you could take, for example, a leaf, and the leaf was made of something. You could just break the leaf apart, and in theory, if you could get a small enough little knife, you could just keep breaking it into smaller and smaller and smaller pieces of leaves. But one guy, a guy named Democritus, proposed something different. So we'll write his name, because he was kind of the first big player. Very Greek-sounding name, Democritus. And he proposed that there is a smallest particle which could not be divided. Well, my pens aren't having much luck today, are they? We'll get a good one here. There we go. And when did this happen? This was about 460 BC. So about 2,400 years ago, almost 2,500 years ago. That's a long time. And so philosophers, what they called natural philosophers back at that time, kind of debated back and forth all these different ideas. And it wasn't until 17 and 1800s that things started to kind of take shape and we started to get evidence for this very idea. So in about 1800 or so we're talking a lot of years later and actually relatively recently, there's a guy named John Dalton. He's kind of our next big player in this story. And he was a scientist, and he was studying what made things up. And he started to notice that when he looked at certain kinds of materials, they always had the same ratio of masses of the things that made them up. And so what he realized was that everything is made up of the same kind of atoms. There's only a certain set number of atoms. We know today there's about 100 and some different kinds of atoms. And he called these elements. So that there's different kinds of atoms that make up different elements. So for one element, all the atoms are identical. But the atoms of different elements are different from each other. So let's outline some of his points that he made. So all elements, and elements were just the things that made up all the stuff around us. All elements are made of atoms. And atoms of the same element are identical. And by that we mean they have the same mass and the same properties. Properties, remember, just means like characteristics or traits. But that atoms of different elements are different. And again, back then, we didn't know about nearly as many elements as we do now. We know now there's about 120-ish, and we're discovering more of them all the time. But that means there are only about 120 different kinds of atoms in this idea. Now, we've learned since then, we'll talk more about this later, that there are some differences between the atoms of the same element. But for the most part, they have the same properties, and all the important characteristics are the same. So that was all thanks to the study by John Dalton. So what was helpful about this is that it could explain not just individual elements, but all the stuff around us is made up of a combination of elements. So atoms combine to form many different compounds. We call compounds those things that form when atoms of different elements come together. Okay? By the time we're done with this semester, we'll have worked our way through an understanding of how those atoms combine chemically and form compounds, and then the compounds themselves can mix together, and we call that a chemical reaction. Now, in hindsight, there was an important flaw, a mistake, that John Dalton didn't know. Of course, we have the benefit of hindsight, but in his atomic theory, atoms were just like a solid sphere. They weren't made of anything. They just were one thing, like a little ball, okay? But since then, we have discovered that atoms are actually made up of what we call subatomic particles. And those discoveries came about a century later. All right, so let's skip ahead to now about 1900 or so. I'm just giving rough idea. Oh, I shouldn't have a comma in there. About the year 1900. We don't put commas in years typically. So the next big player is a guy known as J.J. Thomson. So he discovered, and I'm not going to get into all the detail of his experiments, he discovered that atoms are actually made up of smaller particles. And these particles had a characteristic he called charge. We call it now positive and negative charge. So he sort of realized that it wasn't just one solid thing as John Dalton had thought. So we'll call them positive and negative parts. But that was a significant thing to realize that there are actually components or pieces to these atoms. Now that doesn't get around the idea that you can't break an atom any smaller than it is, because if you break an atom apart of an element, you don't have that element anymore. Okay? You have all the pieces that make it up, but you don't have that element anymore. So J.J. Thomson was getting a little closer to what we know now for the structure of the atom, but his flaw was that these were all like mixed together. The positive and the negative parts all mixed together around each other. And a great example our textbook uses, like chocolate chip ice cream. Where you got the chips all mixed together around the ice cream itself. But the next important discovery showed us a little bit better about exactly how these positive and negative parts of the atom are actually arranged. So the last big player that we'll mention is a guy named Ernest Rutherford. Again, he was right around the year 1900 as well. But what he discovered the very dense positive center, which we call the nucleus of the atom. So a very dense center surrounded by the negative particles, which we call electrons. So instead of being all mixed together, if I could maybe represent it this way a little bit, what he did was he bombarded atoms with little rays of particles, and he noticed that some of them would bounce off violently, almost bounce straight back like they were hitting something and coming back, but most of them passed straight through. So we realized that most of the atom was actually empty space. Nothing would reflect, cause these rays to reflect. But every now and then it would hit one of these dense parts, the nucleus as we call it, and it would bounce right back or scatter off in weird directions. So then all around this dense center is the rest of the atom, the negative part. Okay? So this is getting a little closer to what we understand today for the structure of the atom. So if I just kind of label this here, here's the nucleus. And this is the negative charge. And I'll describe a little bit more in the next section, just exactly what we know now about what the nucleus is, what the negative charge is, and a little bit about how those are arranged relative to each other. But I think we're going to stop here. So all I want you to know is some of these key players, again, going back to Democritus first, and then John Dalton, and then we got J.J. Thomson, and then finally Ernest Rutherford. So if you can know kind of the key contributions from each of those, you'll be in great shape. I'll give you a chance to kind of check that out here. Okay? So if you need to go back and check any of these, you can certainly fast forward or reverse through any part of the video, but that'll do it for now until the next section.